Hello everyone, I welcome you all to chapter 5, that is States of Consciousness, as and under the course of Basics to Psychology. I hope you'll enjoy listening to it. So today we are going to talk about consciousness. What is consciousness? Consciousness is defined as a subjective awareness of ourselves and our environment. The experience of consciousness is fundamental to human nature. We all know what it means to be conscious, and we assume that other human beings experience their consciousness similarly to how we experience ours. The study of consciousness has been long important to psychologists and plays a role in many important psychological theories. For instance, Sigmund Freud's personality theories differentiated between the unconscious and the conscious aspect of behavior, and present-day psychologists distinguish between automatic, that is unconscious, and controlled, conscious behaviors, and between implicit, that is unconscious, and explicit, conscious memory. Some philosophers and religious practices argue that the mind or soul and the body are separate for entities. Like, for instance, the French philosopher René Descartes was a proponent of dualism, the idea that the mind, a non material entity, is separate from, although connected to the physical body. In contrast to the dualists, psychologists believe that consciousness and thus the mind exists in the brain, not separate from it. In fact, psychologists believe that consciousness is the result of the activity of many neural connections in the brain. The study of consciousness is also important to the fundamental psychological question regarding the presence of free will. Although we may understand and believe that some of our behaviors are caused by forces that are outside our awareness, that is unconscious, we nevertheless believe that we have control over and are aware that we are engaging in most of our behaviors. To discover what we or even someone else has engaged in a complex behavior, such as driving a car and causing severe harm to others without being at all conscious of one's action, is so unusual as to be shocking. Our experience of consciousness is functional because we use it to guide and control our behavior and to think logically about problems. Consciousness allows us to plan activities and monitor our progress towards the goals we set for ourselves. The consciousness is fundamental to our sense of morality. We believe that we have the free will to perform moral actions while avoiding immoral behaviors. But in some cases, consciousness may be aversive. For instance, when we become aware that we are not living up to our own goals or expectations, or when we believe that other people perceive us negatively, in these cases, we may engage in behaviors that help us escape from consciousness. For example, through the use of alcohol or other psychoactive drugs, like marijuana, that is weed, and etc. Because the brain varies in its current level and type of activity, consciousness is transitory. If we drink too much coffee or beer, the caffeine or alcohol influences the activity in our brain and our consciousness may change. When we are anesthetized before any operation or experience a concussion after a knock on the head, we may lose consciousness entirely as a result of changes in brain activity. We also lose consciousness when we sleep, and it is with this altered state of consciousness that we will begin this chapter. Many biological rhythms are coordinated by changes in the level and duration of ambient light. For example, our winter turns into summer as the night turns into day. In some animals, such as birds, the pineal gland in the brain is directly sensitive to light, and its activation influences behavior such as mating and annual migrations. Sleep is also influenced by ambient light. The ganglion cells in the retina send signals to the brain area above the thalamus, called as the suprachiasmatic nucleus, which is the body's primary circadian pacemaker. The suprachiasmatic nucleus analyzes the strength and duration of the light stimulus and sends signal to the pineal glands when the ambient light level is low or its duration is short. In response, the pineal gland secretes melatonin, a powerful hormone that facilitates the onset of sleep. So now we know how the sleep gets induced, and we never know when we fell asleep. Now, what are the sleep stages? Like, how do we move through the night? Although we lose consciousness as we sleep, the brain nevertheless remains active. The patterns of sleep have been tracked in thousands of research participants who have spent nights sleeping in research labs while their brain waves were recorded by monitors such as electroencephalogram. Electroencephalogram, that is EEG. Sleep researchers have found that sleeping people undergo a fairly consistent pattern of sleep stages, each lasting about 90 minutes. So these can be REP, like rapid eye movement. Now, this sleep is a sleep stage characterized by the presence of quick, fast eye movements and dreamings. REM sleeps account for about 25% of our total sleep time. During REM sleep, our awareness of external events is dramatically reduced and consciousness is dominated primarily by internally generated images and a lack of overthinking. During the sleep stage, our muscles shut down, and this is probably a good thing that it protects us from hurting ourselves or trying to act out the scenes that are playing in our dreams. The second major sleep type is non rapid eye movement, non REM. It is a deep sleep characterized by very slow brain waves that is further subdivided into three stages, N1, N2, and N3. Each of the sleep stages has its own pattern of brain activity. Now, the brain waves that are recorded by EEG as we sleep show that brain's activity changes during each stage of sleeping. When we are awake, our brain activity is characterized by the presence of very fast beta waves. When we first begin to fall asleep, the waves get longer, alpha waves, and as we move into stage N1 sleep, which is characterized by the experience of drowsiness, the brain begins to produce even slower theta waves. During stage N1 sleep, some muscle tone is lost as well as most awareness of the environment. Some people may experience sudden jerks or twitches and even vivid hallucinations during the initial stage of the sleep. Normally, if we are allowed to keep sleeping, we will move from N1 to N2 stage. During N2, muscular activity is further decreased and conscious awareness of the environment is lost. This stage typically represents about half of the total sleep time in normal adults. Stage N2 sleep is characterized by theta waves interspersed with bursts of rapid brain activity known as sleep spindles. Now we come on to stage N3, also known as slow wave sleep. It is the deepest level of sleep characterized by an increased proportion of very slow delta waves. This is a stage in which most sleep abnormalities such as sleepwalking, sleep talking, nightmares, and bedwetting occurs. The sleepwalking murders committed by Mr. Parks would have been occurred in this stage. Some skeletal muscle tone remains, making it possible for affected individuals to rise from their beds and engage sometimes in very complex behaviors. But consciousness is distant. Even in the deepest sleep, however, we are still aware of external world. If smoke enters the room or if we hear the cry of a baby, we are likely to react even though we are sound asleep. These occurrences against demonstrate the extent to which we process information outside consciousness. After falling initially into very deep sleep, the brain begins to become more active again, and we normally move into the first period of REM sleep about 90 minutes after falling asleep. REM sleep is accompanied by an increase in heart rate, facial twitches, and repeated rapid eye movements that give the stage its name. People who are awakened during REM sleep almost always report that they were dreaming, while those awakened in other stages of sleep report dreams much less often. REM sleep is also emotional sleep. Activity in the limbic system, including the amygdala, is increased during REM sleep and the genitals become aroused, even if the content of the dream we are having is not sexual. A typical 25-year-old man may have an erection nearly half of the night, and the most common morning erection is left over from the last period before waking. Normally, we go through several cycles of REM and non REM sleep each night. Now, the length of REM portion of a cycle tends to increase through the night from about 5 to 10 minutes early in the night to 15 to 20 minutes shortly before awakening in the dream. Dreams also tend to become more elaborate and vivid as the night goes on. Eventually, as the sleep cycle finishes, the brain resumes its faster alpha and beta waves, and we awake normally refreshed.